So for example number 22, we've got right here the equation, which is x squared minus 5 equals the square root of 3x. And so let me get my little paper here. So what they're asking us to do is use the quadratic equation to solve this this equation. So let me write this down. So we've got problem number 22, and I've got x squared minus 5 is equal to the square root of 3 times x. Is that right? All right. So this is what we need to find out. Now, the only way I can use the quadratic equation, remember the quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that only works if I can make my equation look like ax plus bx, ax squared plus bx plus c equals 0. I mean, that's a lot of stuff to write down. So I've got some work to do. I've got to move this square root of 3x over to the other side of the equal sign to solve for 0, right? So when I do that, I get x squared minus the square root of 3x minus 5. Did I write it down wrong?
Oh, no.
No, it'd be minus, right? And all that equals 0. Okay? You guys are looking at it and you're like, square root, oh no, what's going to happen?
Oh no.
Yeah, okay. So it's a equals 1. What does b equal? Yeah, the negative square root of 3. That's okay. We'll be all right, right? We're experts in the field of mathematics. We can do this.
We?
Okay, I'm an expert in the field of mathematics. You guys are, they used to say that I'm the wizard and you guys are apprentices, right? So we say x is equal to negative b plus or minus the square root of, here we go, b squared minus 4 times a times c all over 2a. And now we're just going to plug this in. X is equal to negative, negative times a negative is a positive, so that's positive square root of 3, right? All right, plus or minus, then in here I'm going to have the negative root of 3 squared minus 4 times a, but a is 1, times c, but c is negative 5, all over 2 times a, which is 1. Am I going too fast? All right, next line. X is equal to the square root of 3 plus or minus. When you square a square root, you get the principal root, which is going to be just the base. So this should be 3. And then negative 4 times 1 is negative 4 times negative 5 is positive 20. Yeah.
So you get rid of the negative sign and the negative square root of 3 when you square it?
Yeah, because this is technically the negative of the negative. So what's a negative times a negative? A positive. So it becomes positive square root 3.
I was talking about the one
That in the square root.
Yeah, so this is going to be negative times a negative, which is,
Oh, okay.
okay. You guys see that?
Yeah.
This is the negative root 3 times the negative root 3. Well, the negatives will cancel, so it becomes positive. So then we have x is equal to the square root of 3 plus or minus the square root of 23 all over 2. And now the book in our example problems didn't really specify whether or not it had to be a decimal or if you had to leave it in the exact value. What number was that problem? 22? I can tell you the answer. We want to double check the answer here. Okay, well, it just so happens my teacher book is probably on the other page or something, and I'm just too tired and in a hurry to look. So what we're going to do is let's crank through this. So now what we could do, Mr. Adams has got to fire up his calculator. Alright, so here we are. We're going to fire up the calculator. So if I say the square root of 3, right, and I'm going to do plus the square root of 23, I get 6.25788, all that stuff. Then I got to divide by 2. So that should be one of my answers. Okay, so I'm going to write that down over here on my paper, and we'll come back and verify that in a second. 3,264 if we round up. Okay, and then I've got to do the exact same thing again. Square root of 3 minus the square root of 23. I'm hoping that we didn't make a mistake. Bless you. And then that becomes that. Divide by 2. Good to go. So then another possible solution is x is approximately negative 1.532. Alright, so now what we'd like to do is we want to, Mr. Adams can't find the answer in his textbook. Earlier somebody said, why do we need to look it up graphically? Well, I can solve this graphically. So if I come in here and I plug in the original equation, which was x squared minus the square root of 3 times x minus 5, it should cross at 3.264 and negative 1.532. Okay, so I'm going to move this over here so we can see my possible solutions, and that looks about right. So let's just do let's do a trace. If I say negative 1.532, now remember Mr. Adams did some rounding, but doesn't that cross it pretty darn close to y equals 0?
Yeah.
Yep. And let's do the same thing for 3.264. Yep, pretty close to y equals 0. Now, we could use the calculator if we wanted to calculate a little more precise value. But remember, Mr. Adams rounded. So I feel pretty confident as long as I didn't write it down wrong out of the textbook. It's a great way to double check those even problems, right? That was an even problem, not in the back of the book.
How about
You want to do another one?